This test won't be until like next Thursday, not this Thursday, but the next. So that'll be good. So we're gonna do both 6-1 and 6-2 today. 6-1 is what we've been doing. 6-2 is going to be a little bit of what we've been doing, and then some new stuff as well. Okay, so radical functions that we're going to be looking at there. So you've heard me talk about a couple of these things, but you might not have understood what I was actually referring to. So if you have a little number, which in most cases we have not had this little number up here. If nothing's there, it's a 2. That's why we've always dealt with square roots. That's called your index. Okay, so now we're going to be looking at higher roots, like cubed root, 4th root, 12th root, and so on. That's your index. That's important, especially in your answer. Okay, you've got your radical symbol. You've got what's underneath the radical symbol. That is your radicand. And then you have the entire thing, which is the radical. Okay, so those are the definitions of those words I've been saying that you might have been like, what is that and where did that come from? Okay. So let's review. We were able to find perfect squares that went into a lot of these, like 200. We'll probably be able to find one. But remember, we use the prime numbers 2, 3, 5, 7, 11, and 13 to break these down. So I'm going to use that ladder method for all of these, only because it's going to help when we get to cubed roots, 4th roots, and so on. Okay. So as a review, go ahead and simplify both the square root of 512 and the square root of 200. And for those of you who have not been here when I went through this method, I'm going to go through it plenty of times that you'll be able to catch on. like I said, with 200, that was one that you probably know a perfect square that goes in there. I can say the square root of 100 times the square root of 2. So that gets me 10 square root of 2. If I did not know that, again, I can do this ladder method. So for those of you who haven't been here for that, this is how this works. I can divide by only prime numbers, okay? So if I take 200 and I divide it by 2, I get 100. And then I can keep going. Divide it by 2, I get 50. I can divide it by 2 here, or I can divide it by 5. It doesn't matter. I just keep going. And then I stop when I get to another prime number. It's like the old factorization trees that you used to do. So then I could say if I'm doing my index is 2, I have one pair of 2s and one pair of 5s. So those get multiplied together on the outside with a 2 left over on the inside. Okay. So remember, that's the method if you don't know a perfect square that goes in there. Y'all, we're going to get to 7th roots and stuff like that. I don't know about y'all, but I don't really have those memorized like I do maybe perfect squares. So this method helps a lot with that. Okay. So if I divide 512 by 2, what did y'all get? 256. Divide that by 2, you get 120 what? 128. 8. Divide that by 2, you get 64. This one look familiar to anyone? These numbers? Anyone play that game? 2048. Those are the numbers. So divide that by 2, we get 32. Divide that by 2, we get 16. Divide that by 2, we get 8. And then we just keep going until we have a prime number. Okay? So, again, this is the square root. So I'm interested in pairs. So I have one pair. I have 2 pairs. Let's see. Here's another pair. And I've got one more pair. And then I look and I notice that I have 1, 2 that's left over. So that has to stay inside. And then 2 times 2 times 2 times 2 gets me what? 16. So we've been doing this. We're going to continue to do more examples like this today. We're going to add in higher roots. We're going to add in variables and so on. But this is basically what we're going to be doing today. So that's why I said it's a nice one to go into after fall break. Okay. Any questions so far? Okay. So what if we do go higher in our index? That's fine. Instead of finding 2 of a kind, I'm going to find 3 of a kind. I'm still going to divide it out like I did on all the other problems, except instead of circling 2 things that are the same, I'm going to circle 3 things that are the same. So go ahead and try 320. The cubed root of 320. If you are a visual highlighter kind of person, what I would do is I would highlight or circle the index so that way you know I am finding 3 of a kind. I'm just adding these to the screen that I'm sharing so that way I don't have to do two different videos. Okay, sorry about that. So if I take 320 and I divide it by 2, I get 160, and so on. Okay, so again, I'm going to acknowledge, hey, this is my index. Another good thing about highlighting it is when you get to your answer. This is where a lot of people lose points, okay? So if I'm looking at this and I say, okay, I'm doing 3 of a kind. So I've got one set here. I've got another set here. And then I've got a 5 left over. This answer right here is wrong, okay? There is a huge difference between the square root of 5 and the cubed root of 5. You have to put that index in there. So that's why I said if you're somebody that is a visual person, I would highlight, circle, I would do whatever it takes to not forget that little number because it changes the answer, okay? Huge difference between the cubed root of 5 and the square root of 5. So you have to have a little index in there, okay? Some of us might know the cubed root of 64. Some of us might not, okay? Normally, we've been trained that if we see a negative under the radical, we start freaking out and we're like, imaginary number, okay? That's if it's an even index, okay? An even index, we're dealing with that imaginary number, okay? But if you think about it, I can sit here and say -2 times -2 times -2. That gives me -8. So the cubed root of -8 is -2. We are allowed to have a negative, okay, when it's an odd index. So if I take 64 and I start dividing it out, okay, and I'm looking for 3 of a kind. Well, conveniently, I had 2 3 of a kinds. And then just because I have this negative in here, it makes it negative, okay? So in other words, don't use the negative when you're breaking down the ladder. That's just another thing to write, okay? It's going to be a waste of time. It's going to be something else you have to write, and it just gets in the way. Just write it as a part of your answer at the end, okay? Any questions so far on reducing radicals?
Isn't it -4 square root 2? Or
-4 what? I'm sorry?
Or -4 cube root of 2.
Did you have a 2 left over?
Yeah.
Did you keep going? Did you divide 2 divided by 2?
No.
You shouldn't have anything left over.
Yeah.
Okay. Now, if I did have something left over, yes, it would go inside the radical. Okay, so I want y'all to try just the first 3. Don't worry about the last one. You can try it if you have extra time, but I think you'll get the process of it in the first 3. Acknowledge the index. Remember, just the first three is plenty. All right, so 648, I can take that and divide it by 2. 324. Divide that by 2, I get 162. Divide that by 2, I get 81. Then I'll switch off to 3s. Okay, so in this particular example, I am acknowledging that my index says 4. So I need 4 of a kind. I only have 3 2s, and I do have 4 3s. So that comes out, and I keep that 4 with my index, and I have 2 times 2 times 2, which gets me 8. Okay. I can take 192, divide it by 2. What do you get? 96. Divide that by 2. What do you get? 48. Divide that by 2. We get 24. And we keep going until we get to another prime number. Here I'm interested in 5 of a kind. So I look for 1, 2, 3, 4, 5 2s. Okay, and I have a 2 and a 3 left. So I have a 2 that comes out, and I'm left with the 5th root of 2 times 3, which gets me 6. Okay. And 512, if we divide that by 2, what did you get? 256. And then this looks a lot like what we were just doing. 256 divided by 2? 128. 128 divided by 2? And we've already done one majority of the way through this one. Okay. I am interested in 6 of a kind. 1, 2, 3, 4, 5, 6. So a 2 comes out. I'm left with 2 times 2 times 2, which leaves me with 8. So I'm left with the 6th root of 8. Any questions with these higher roots? Besides the fact that you're writing numbers in lines for days. That's more of a comment than a question, but any questions? Okay, the good thing is the next thing we're adding to this are variables. Well, if I give you a set of variables that are inside the radical, really nothing's stopping you from doing the same thing. Okay, and what I mean by that is, what if I give you an example? Let's do 216. just right now, I want you to break down 216. Don't worry about the variables just yet. Just 216. So I'm back to a square root, which means 2 of a kind. So I have a 2 and a 3 that comes out. And I have a 2 and a 3 that stays in. Okay? My variables, some of us, if I say, what's the square root of u to the 4th? We know what it is. Some of us are like, what? Okay? Nothing is stopping you from expanding those variables. Some of us are visual people, okay? So if I do that, then I'm doing the same exact thing I was doing on this here. I have 1 pair, 2 pairs. So u squared. I have 1 pair, I have 2 pairs. So b squared. Probably would give myself a little bit more space than that. Some of us realize, hey, why don't I just divide the exponent by the index? Cool, do that. But what if I have a remainder? That's fine. That's what's left over. Okay? So there's a lot of different methods to approach these. I'm going to show you different ones. And then whatever works best for you, go for it. Okay? Let's do this third one down here. The cubed root of 81 x to the 5th y cubed. Now, for my really big visual people out there, this is for you. Some people need to see it all laid out. Is it more writing? Yes. But will it help you? 100%, especially with like test anxiety when things just get all over the place. If you want to write down everything you came up with on this ladder, so 3 times 3 times 3 times 3. And then I expand out my variables. 1, 2, 3, 4, 5, and 1, 2, 3. There it is on the open, okay? Now, I look at my index, and I say I'm looking for 3 of a kind, okay? Here's 1, 2, 3, okay? So I have a 3 that comes out, an X that comes out, and a Y that comes out. Then visually, and if I circled these, it'd probably be a little bit easier to see. Now it's easy to see what is left over, okay? What stays inside? A 3 and 2 X's, okay? So if you're a visual person, there it is, all in one line. You go through and you say, these are all that are 3 of a kind. This is all that's left over, okay? Is it annoying to expand some things out that far? Absolutely. But is it going to get you the right answer? Yeah. So here's what I mean on those of us that are seeing the exponents with the index. If I say 3 goes into 5 once with 2 left over, here's your once with 2 left over. So if you see it that way, that could be helpful too. Okay? Any questions on that? Okay, try the next one. This is why it's super important that if you want me to know something is an index, you need to make sure it's inside that radical sign, okay? Because some of y'all might have looked at this and said, did you mean to put that 3 up there as an index? Nope. It's being multiplied in the front, okay? So that's why you need to make sure when you write your answers that your index is where it's supposed to be. So this is 3 times the square root of 128 p cubed. What I would suggest doing is leaving it like that as a blank and dealing with it later. That 3, you don't want it to get lost. Oops. So we're back to square roots again. So I have 1 pair of 2s, 2 pair of 2s, and 3 pair of 2s. 2 times 2 is 4. times 2 is 8. And I have a 2 left over. If I want to expand out my variables, I now have 1 pair with 1 left over. So then the 3 is only being multiplied to the 8. Don't start distributing it through all kinds of things. So your final answer should be 24p, the square root of 2p. Okay, so if you have a number in front, it just gets multiplied to the numbers in front of that. Okay. All right, let's look at one more, and then we'll take a break. Hold on, where is it? Maybe the one I'm thinking of is on the other thing. Okay, let's go ahead and take a break. And then we'll do multiplying and dividing. Okay, let's come back from our break so we can knock these out and maybe start our homework. So with rationals, we were able to, if we knew how to simplify, we knew how to multiply, we knew how to do all those, and we could divide. Well, it's kind of like with radicals. If you can simplify, you can multiply, but the division part's going to be different, okay? But multiplying is just like simplifying. You just have one step before you do what we've been doing, and that is to multiply, okay? So the two properties that we're going to look at here is that if you have the same index, that's it. That's all I'm worried about. They have to have the same index. Then if I am multiplying them, I just multiply the two numbers inside of the radical together. Okay? If they have the same index, I am allowed to multiply the two together on the inside. Just as much as I'm able to go backwards, like the first example that we did where I took the square root of 200 and I wrote it as the square root of 2 times the square root of 100, I can go backwards with that property. I can take it apart as much as I want to, okay? Then division, if I have the same index on top of the same index, I can write it as one big radical, okay? I can go the other way. If it is one big radical, I can separate it out as two radicals, okay? So those properties, I can go forward or backwards. Okay, so I can split it up or I can put them together either way. And we're going to use these two properties to approach both multiplication and division. Multiplication, like I said, is just like simplifying, except you have to multiply at the beginning. So for example, let me start with something small. Let's do square root of 5 times the square root of 12. Okay, so what you could do is you could simplify each one individually and then combine them. Or at the beginning, you can use that property and say, well, they both are square roots, so I can write that as the square root of 60. Now I can do what I've been doing for 35 times now, it feels like. I can break down the square root of 60, okay? So I can just go through and start dividing. So then I end up with 2 square root of 15. So the property says I can multiply those together. They have the same index. I'm good to go. Okay. The only way this gets more complicated is the numbers get bigger and there's variables. Okay. The only way this gets to be more difficult. So I'm not going to sit there and really waste a lot of your time with a couple of these. We're going to do a couple of examples. But I feel like we've done 1,000 of these ladders already. But I still want to make sure you get some examples in. Okay, so let me cover these up. We're not doing all of them. Go ahead and try 1 and 2. Like I said, the way these get harder is the numbers get bigger. So for example, the first one, some of y'all might have noticed, oh, the cubed root of 125. I know what that is, that's 5. Okay, you could do that, great. You just saved a lot of time. If you can't do that, that's okay. Because you can then just multiply them out. So if I multiply 125 times negative 20, I get negative 2,500. If I break down 2,500, I end up with 5 cubed root of 20. And then I just take that negative and I pull it out of the cubed root, and that's my final answer. Okay? So it's just like simplifying, you just have to multiply at the beginning. But if you catch on to the fact that something can be simplified before multiplying, do it. But nothing is going to be wrong with your answer if you don't do that. Okay? So if I take 192 times 4, I get 768. What do I do with those numbers in front? I'm sorry? Leave them out, but do what with them?
Bring them back later.
Okay, multiply them. All right, so I'm just going to leave this negative 8 out here until I get to my final answer. Okay, so then now I'm going to break down 768. If I divide that by 2, I won't bore y'all with all of that, and my mind's not wanting to do that right now. And of course, I'm running out of room. 24 divided by 2, I get 12 divided by 2. This is not working out like I want it to. I'm just going to go into this one down here. Okay, so I want 4 of a kind. I see 1 here. I see 1 here. So that means I have a 4 here. And I have a 3 left over, so I have the 4th root of 3. So my final answer would just be negative 32, 4th root of 3. Okay. So again, all of these problems, we're just simplifying really. There's not anything too extreme about it. That's why I said I'm not going to bore y'all with all of these where it's literally the same thing over and over again. Yeah.
Does the negative have to be on the number outside of the radical, or can it be inside of the radical?
Outside of the radical, so it's this one, it is outside because it was outside to begin with.
Yeah.
And if you put it inside, you've made it imaginary. And it wasn't imaginary.
Well, what about on
This one?
on the first one? Yeah.
So this one, with it being completely simplified, you want it out. Okay. So like I said, we'd just be doing the same thing with all these problems. Okay. So I'm not going to waste your time with those because it's the same process. Any questions on multiplying? Yeah.
Where did the negative 5 come from?
Where did the negative 5 come from on this one?
Is it just because the negative 1,500 is negative?
Yeah, so the negative that was inside here, I just bring it out. And then I had 1, 2, 3, a pair of, or 3 of a kind of 5. I know you can't see it over there. And then the rest. Any other questions? Okay, let's look at some division problems. Now these are different. You're going to figure out ways to make these quicker to solve. You might be one of those that say, hey, you teach me one way to do every single problem. I'm going to do every single problem that one way. Okay? So some of y'all might say, oh, I feel like I can do some simplifying before I make things a little bit more crazy. So looking at 31, remember when we were doing imaginary numbers, I said we couldn't do imaginary numbers in the denominator. Because what is the imaginary number? It's the square root of negative 1. Well, why was that such a big deal? you can't have a radical in the denominator, all right? So when we run into these particular problems where we have a radical in the denominator, we need it to disappear, okay? How do you think we can make the square root of 2 disappear without squaring it? Huh? Anybody? How can we make the square root of 2 disappear, or the square root disappear, but squaring it is not an option? Yeah?
Multiplying the numerator and denominator by square root of 2.
Absolutely. Good job. So if you think about it, whenever we're manipulating things, we multiply it by 1, technically, right? Because it doesn't change the value of the problem. What it does is it changes the way it looks. And that's our goal. We want to change the way it looks. So if I multiply by the square root of 2 over the square root of 2, I'm just multiplying by 1. I didn't change the value of the problem. I'm just going to make it look different, okay? So why would I do that? Well, my numerator, I end up with 2 square root of 2. My denominator, I end up with 2 square root of 4. But the square root of 4 is 2. So it's almost like squaring it without squaring it. Can I reduce that further? Yeah. So my 2 over 4 then reduces. So my final answer is just the square root of 2 over 2. So basically what you're going to do, if it is a square root, okay, the index is 2, you're just going to multiply it by itself on both the numerator and the denominator, okay? Because if we multiply by itself, the square roots disappear and you're just left with the number that's in there, okay? Now, could you do that same thing for 32? Absolutely. Can you make your life easier on 32? Even better, okay? So that property I taught y'all at the beginning. Let me get a different page here. 3 square root of 20 over the square root of 15. So that property at the beginning of class today, I told you if you have a radical with the same index over a radical with another same index, you can write it as one big radical, okay? So let's do that. The same thing, and then that's 20 over 15. Could you start at the beginning of this problem and multiply by the square root of 15 to both the numerator and the denominator? Absolutely. You would just have to do more simplifying at the end, okay? So how does 20 over 15 reduce? 4/3. If it helps you too, some people might be confused by this 3 floating around. You're like, is that an index? Is that a constant? What is that? You want to put it over 1? You can go for it. Okay. But just like I said, you can write it as 1 fraction. You can take it out of the 1 fraction as well. Okay. So what I mean by that is then we can write it back to where it looked like before. 3 square root of 4 over the square root of 3. Well, the square root of 4 we know is 2. So now we're at 6 over the square root of 3. Now, these particular examples, I'm showing a ton of work. Will you have to show all of this when you're actually understanding them? No, but this is to show you the process. So now I can just simply multiply by the square root of 3. So 6 square root of 3 over what would be the square root of 9. The good news is if you're multiplying it by itself with the radicals are gone. You just have that 3. So then my final answer is just 2 square root of 3. Okay. The division, if you can find ways to get around multiplying big numbers, go for it. If you're someone that's like, hey, I was doing good until you started doing like shortcuts, then stick to the old way. Start at the beginning. And multiply by the square root of 15. And then whatever 15 times 20 is, okay? That's fine. Do you have to do the ladder and reduce it? Absolutely, okay? But if that helps to break it down a little bit further, I would do that, okay? All right, let's try another one of those. Go ahead and try 34. That one's not as hard on you. Try 34. So if I just multiply by the square root of 2, I end up with 3 square root of 6 over 2. I can't simplify the square root of 6, and 3 over 2 does not reduce. So that one, like I said, was a little bit more straightforward. Not as much simplifying in the end. Okay. Let's check out 33. On this particular problem, you cannot just multiply it by itself, okay? But what you can do is see, hey, can I reduce 4 over 32 first? Yeah. So let's go ahead and try that first. What is 32 divided by 4?
28.
Did you say 20?
No, I was gonna say 1 over 8, which is what and
Gotcha. I don't know why I heard 20. I was like, that's fine.
dude,
We're a
I'm
little off.
on like 2.5 hours of sleep right now.
You had a whole week.
So, yeah.
Holy.
I took a nap in the middle of the day yesterday, so I couldn't sleep. You know, like,
Hold on. There we go. I ran out of room. All right, so So if I move that back, we know anything, the 6th root of 1, the 12th root of 1, or whatever, is still going to be 1. So right now I'm just left with this. Okay? So in some cases, I could multiply it by itself and it would disappear. But when you get anything higher than the 2nd root, you can't just do that. You can manipulate it a little bit if you need to. But what you have to look at is, I need the radical to disappear. In order for the radical to disappear, I need 6 of a kind. Okay? So this is where some of us that are really good at numbers catch on quick. This could be where some of us are like, I need to sit down tonight and relook at this, okay? But what I could look at is I could look at 8. I know that that is 2 times 2 times 2, right? So that's 3 2's already. How many do I need to have 6 of a kind? I just need 3 more. So in this particular case, yes, I can get away with multiplying it by the same thing, okay? Some of us might not have seen that. And you might say, hey, I know that I have 1 8. I need 5 more 8s. And you can approach it that way, all right? But when we want that radical to disappear, it has to be 6 of a kind, so then that goes away, all right? So if I notice the 2's, then I know that I can multiply. And if I wanted to write it out, I could, or I could write 8. It doesn't matter. Okay? Because in reality, now I have 6 2's, so the radical disappears. Okay? We'll do some more examples, don't worry. So we end up with 3 with the 6th root of 8 over 4 times 2. So then I end up with 3 6th root of 8 over 8. Now, that is the most simplified way and the easiest way to approach it if you know numbers. Okay, let's do something a little bit smaller than that. It's a little bit bigger number. Let's look at 36. Now, I know I can't reduce 5 over 4. I'm going to show this problem 2 different ways. Okay? The first way is if I know that 2 times 2 gives me 4, but I need 3 of a kind. So I need 1 more 2. So if I notice this, I can multiply by the cubed root of 2 and the cubed root of 2. Because I know that with this 4, I have 2 times 2. I just need 1 more to make it 3 of a kind. Okay? If I saw that, then great. If not, I'm going to show you if you did not see that. Okay, if you did not see it, you might have said, hey, I see 1 4. In order for this to disappear, I need 3 of them. So I need 2 more 4s, okay? So if I multiply by the cubed root of 4 times 4, or if you write 16, that's fine too. Some of us need to see 3 4s, okay? So then from there, I just end up with a 4. And then if I have 16 times 5, I can, 150 or 80. Wow. Y'all, welcome back. 80. But then now you're left with, I gotta reduce the cubed root of 80. So it's almost like each method has its pros and its cons. Either I'm really good at number sense and I can catch on at the beginning, great. If not at the end, I have to do a little bit more simplifying. So I'd have to break down the cubed root of 80 and then simplify from there. Both of them will get you the same answer. Questions? The higher roots are the harder problems. This is the difference between an honors class and a CP class. I would have not have done cubed roots, fourth roots, and whatnot with my CP kids, okay? Huh?
I switched to CP for that.
Come on. Would you do your homework there? I'm sorry, did you say yes or no behind your mask?
I said, I didn't say anything. It's a good question.
He's not making any promises.
Yeah. If you do your homework there, that'd be great.
She didn't give me the CP homework.
But these are a little bit more difficult. I get that.
Yeah, what if I just CP?
Okay. Let's see if I've got, we can just do one more. Just kind of like 35 and 40. See how you have perfect squares that you could knock out at the beginning? I'd do that. Okay. So in this particular case, I would do 2 times 3. So I had 6 over the square root of 6. Save yourself some heartache. But for the most part, these are more the straightforward ones. Okay. Your homework, I don't have a submit thing up just yet. I'm going to do it during my plan period. But your homework tonight is both 6-1 and 6-2 on the assignment sheet. The assignment sheet's up already on Canvas. And it's just going to be these 2 right here. Okay, so you'll have your simplifying and then you have your multiplying and dividing. So this is a little bit of a longer chapter, how it's broken up. But as you can see, we've already done Monday, then Tuesday, Wednesday, Thursday, Friday, Monday, Tuesday, Wednesday, and then that history test on Thursday. Okay? So 6-1 and 6-2 for tonight. And we'll keep going. Oh, I can't get to my screen testify down here. How do I bring it back? Oh, there we go.